All right, the next thing that we're going to learn about in our brief little bit of statistics in Math 3 is data collection. So we have three different methods of data collection we're going to talk about. They are studies, surveys, and simulations. So there are two different types of studies. That's what the primary assignment is going to be about today, is the two different types of studies. So first we have observational studies. And an observational study is where the researcher observes but does not influence the outcome. So picture you are behind the glass, watching what happens, taking notes, but the person, the animal, the whatever being observed doesn't even know you're there, is not acting any differently, has no idea that somebody's watching them, is just kind of going about their life, living their life, and you're sitting there kind of taking notes, seeing what's going on. The second type of study is an experiment. So in an experiment, the researcher is influencing the subject and then observing the outcome, observing that effect, and taking notes on that instead. So observational study, you're observing but not influencing. Experiment, you mess with them and then you see what happens. All right. Another type of study is a survey. A survey would be considered a questionnaire or an interview. And then last, we have a simulation. A simulation is a way to model random events. Such that simulated outcomes closely match real world outcomes. If we had time, we would have done more with simulations, but unfortunately, this is just us kind of running out of time. So, simulations are kind of a mathy sort of thing. So, one year when I did have more time to teach simulations, the real world outcome that we modeled was like a coin flip. Coins have heads and tails, so you have a 50% chance, in theory, of getting heads, a 50% chance of getting tails. But if you actually sat down and flipped a coin 100 times to get heads versus tails, if you sat down and did it 100 times, you wouldn't actually get 50 heads, 50 tails. It would be close to 50-50, but not quite there, if everybody in the classroom did it. And so the simulation that we came up with is we wrote like a computer, not a computer, but like a calculator program that would simulate something that was approximately 50%. But when you sat down and did it, it did the same thing where it was like maybe one person in the class had that 50% and then did heads, tails on the calculator instead. And they came up with like 49% heads, 51% tails, that sort of thing. Or not percentage, but when they did it, their simulated outcome, when they were pressing the button on the calculator to simulate a coin flip, did the same thing. So that's the idea of a simulation, is that you're like using a program or something like that to do like what the real world would have done, with something, or you can do it with like colors of Skittles or, whatever, anything that would have had, a percentage chance, a probability of something, or anything else, that had a random event you could do with a simulation. So obviously that would have been a time consuming type of lesson, and we just don't have time to do that. So the last thing down here is almost a mantra of statistics, and it's something that is worthy of talking about because it's something, it's almost a pet peeve of mine, I imagine, especially after college. In my master's program, I took a lot of statistics classes, and I imagine this is a pet peeve of a lot of statistics teachers and people who have taken a lot of statistics classes. But one thing they kept repeating was that correlation is not causation. So as you study things, you'll notice like a statistic. And what we talk about is we'll get like a number fact. We'll say like, oh, this many percentage of this something. And then people, it's a natural inclination to take it a step further and make an assumption about the world or make an assumption about something. And so you'll say there's a correlation there, therefore there's a cause. So for instance, you might say, these students get A's a lot. That's a statistic. That's something that's true about them. These students get A's. And then you'll make an assumption, therefore they're smart. And statistics people would say you can't make that assumption. That cause is not there. They could be getting A's because they work hard. They could be getting A's because they're paying their teacher to give them A's. They could be getting A's because those teachers' classes aren't very difficult. They could be getting A's because they're stealing answer keys and copying them. There's a lot of reasons they could be getting A's that are not because they're smart. So you taking it a step further and assuming the cause is not beneficial. So the idea behind statistics is we are just noticing correlations. We're noticing relationships between things. We are not stating that we know why they're there. We're just stating that we know there's a correlation. So we might say, these students get A's. This type of class, we're noticing that not as many students get A's in calculus and a lot more students get A's in PE. We're not going to make any assumptions about that. We're just going to notice that it's true. If we want to notice any assumptions, if we want to notice why or say that calculus is a harder class, we're going to have to look a little bit more in depth, but we can't make an assumption about why based only on the grades, because it could be that in PE, the answer keys are being given out, and in calculus, they're not. So that's one of the big ideas in statistics, is that correlation is not causation. Just because you have a piece of information that you've noticed does not mean that that has told you the cause, okay? And that's something, especially Americans, we love to make assumptions about things and assume that our opinion is right. If we feel strongly about something, we must be right. And so that's something in statistics that we're being told we cannot do. We can say there is a correlation there. So like, yep, we've noticed that there's a correlation. Students who get really high grades in other classes, they might come and take calculus and have lower grades. There's a correlation there, but the correlation is where it stops. Like, huh, that's an interesting piece of information. Now let's move on. That is about all we can get. All right, so this assignment is not too difficult if you wanted to do it at home, so that you do not have to do it in class, so you can spend the rest of your class time practicing the EOC review. Now that you know how long the EOC reviews are going to take, that is certainly something you could do. All you have to do for this is explain if it's an observational study or experiment, and you don't even have to say why, you just have to determine which one it is. So basically all you have to determine is this something where they were being watched through a window, hands off, or did the researcher have some sort of something where they messed with them? Did the researcher have an influence? So here, the muscles of men ages 40 to 50 were 40 to 50% stronger after they participated in a 10-week high-intensity resistance training program twice a week. So were they messed with? Were they not messed with? It doesn't say that they were forced to participate in the training program. So the choice could have been theirs and they were just watched from afar. It doesn't say anything. Remember, experiments, typically, you might think of this from a science class, typically an experiment is going to have a control group So that might be something that you write here typically. Control versus test group. So just because the group is doing something doesn't mean that it's not an observational study. It still could be an observational study. So for number one, this is an observational study. So yes, they did something, um, but they're not necessarily being forced. Aside from them doing a 10-week high-intensity resistance training program, there's no other stepping in. So maybe it's something where it's like, hey, we are having this training program. Let's kind of watch and see what happens. And then once we watch and see what happens, we can use that information and we can put it in a commercial and we can kind of publicize this is what happened to the men ages 40 through 50. We're glad that it happened. It wasn't an experiment, it was an observational study, but we can use that information and we can use it to bring new customers into the gym or something like that. All right, let's look at 3 next. 40 volunteers suffering from insomnia were divided into 2 groups. The first group was assigned to a special no desserts diet, while the other group continued eating desserts as usual. So here you can tell they're divided into 2 groups. We've got eating desserts, not eating desserts. There's an exercise program, not exercising. Clearly they're being messed with. This is an experiment. So here you've got 2 pretty good examples of what it looks like, observational study versus not.